Question 1A asks for the quadratic function in factor form. So in order to factor x squared plus 6x plus 8, we can use decomposition. So in order to decompose this, we take the coefficient of the x squared, which in this case is 1, multiplied by 8. So we get p, the product is 8. And we want the sum to be the coefficient of our x term, which is 6. So the two numbers, or the two integers that multiply to 8 but add up to 6 are plus 4 and plus 2. So we could decompose our original equation to be y is equal to x squared plus 4x plus 2x plus 8. Now we do a partial factor under this two terms. So here I'm going to pull out an x. So I'm left with x plus 4. And out of this part, I'm going to factor out the plus 2. So I'm left with x plus 4. This brings me so that I can factor out that x plus 4 both out of here. And so we're left with x plus 4, x plus 2 as my factors. So that is the equation in factor form. Now to figure out the zeros, I need to figure out what each of these factors, if each of these factors is equal to 0 because it's being multiplied together, then your answer will be 0. So the zeros is when y is equal to 0. Because when y is equal to 0, that's when we cross the x-intercept. So we set our equation to 0 is equal to x minus 4, so x plus 4, this should be x plus 4, x plus 2, right? So if either x plus 4 is equal to 0 or x plus 2 will equal to 0, then my equation will equal to 0. And those are the zeros of the function. So here I would get x is equal to minus 4, x is equal to minus 2. Therefore, the zeros are negative 4 and negative 2. To calculate the axis of symmetry, what we do is we take the average of our zeros. So the axis of symmetry is x is equal to, so my zeros are negative 4 plus negative 2 over 2. So that gives us negative 6 over 2, which is negative 3. So that means that the x-coordinate of a vertex is negative 3. The direction of opening, well, our a value in this quadratic equation is 1. So because it's greater than 0, the direction of opening is upwards. And finally, to calculate the vertex, well, we know the x-coordinate of the vertex is negative 3. So in order to figure out the y-coordinate of the vertex, we just plug in negative 3 to our equation. So we get negative 3 squared plus 6 times negative 3 plus 8. So that is 9 plus negative 18 plus 8. So 9 plus 8 is 17, so that gives us a negative 1. So therefore, the vertex is negative 3, comma negative 1. So now in order to graph this, we have 3 points. We have a vertex. So here's our scale. We have 1, 2, 3. These are x-axes. This is our y-axes. 1, 2, 3. So negative 3 is over here. Negative 1 is down here. So that's our vertex. Negative 3, negative 1. We know our zeros, or the x-intercepts of this equation, is negative 4, comma 0, because when x is -4, y is 0, and also -2, comma 0. Because when x is -2, y is 0. So there's our 3 points in our quadratic, and there's our vertex. Now to answer the question about completing the square, the first one is nice because x squared, y is equal to x squared plus 10x plus 20. The x squared is already a perfect square, and in fact, it has a coefficient of 1 already. So in order to make this a perfect square, we need to find a value here that will make x squared plus 10x plus this value to be a perfect square trinomial. And we still have, of course, plus 20 in our equation. So in order to get this value that we want here, we take our 10, our coefficient for the x, we take that, we divide it by 2, and we want to square it. So that is equal to 5 squared, which is equal to 25. So we need to add 25 to here, but we just can't add it, any number to an equation, because that will make it untrue. It won't keep it consistent. We have to subtract 25 as well. So now we have our perfect square trinomial right here. So we can factor that to be x plus 5, y squared. And then we want to simplify minus 25 plus 20, which just gives us minus 5. So now we have an equation in vertex form. So therefore the vertex is minus 5, because minus 5 will make this part 0. And then the y coordinate is minus -5, which is just this part of our vertex form. Now question 3 is a little bit more complicated, because for the x squared term, minus 3x squared, that's not a perfect square. In fact, ideally we want a coefficient of 1 on there. So we could get a coefficient of 1 on the x squared by factoring out a -3. So I factor out a -3, and I take out a -3 from both the x squared, the term with the x squared, and also the term with the x in it. So here I'm left with minus 4x, and we're not touching the 13, so that stays outside our brackets, because we didn't factor out a -3 out of there. So -13 is just off on the side by itself. So we ask the same question again. What value do we need to put here? Do we need to add to x squared minus 4x to make that a perfect square trinomial? So we take -4, divide by 2 gives us -2, square that, it's going to be plus 4. But again, like before, just can't add plus 4 arbitrarily, because that changes our equation. Within our brackets, because we added 4 in the brackets, we have to subtract 4 within our brackets. Now we're left with our perfect square trinomial, which is right here. So we have y is equal to minus 3 x minus 2. So that's actually an extra set of brackets here. Let me try that again. So y is equal to minus 3. So that's this big brackets out here. But inside here, we have x minus 2 y squared, because this is our perfect square trinomial, what we're looking for. Minus 4 stays there because we didn't factor that. Minus 13. Now we want to take our -3 and distribute it to this term and to our -4 term. So we get y is equal to minus 3 times our x minus 2 y squared. Then you take -3 times our -4, and we have minus 13. So we go off and simplify this now. We leave the x minus 2 y squared as it is, because that's what we wanted for vertex form. Minus 3 times minus 4 is plus 12, minus 13 leaves us with minus 1. So here we have our equation in vertex form. therefore the vertex is at 2, because 2 is going to make this part 0, comma negative 1.